Welcome to Lesson 2.7, Adding and Subtracting with Scientific Notation. Today we're going to talk about how to add and subtract numbers that are written in scientific notation. Alright, so adding and subtracting numbers in scientific notation is a little different than multiplying and dividing. There are no laws of exponents when it comes to adding and subtracting, and with multiplying and dividing, the laws are different. So with scientific notation, we do end up having to change a couple of things around, but the process is the same for both adding and subtracting. So essentially what you've learned is a way to multiply in scientific notation, divide in scientific notation, and then add and subtract in scientific notation. So what we're going to do is we have these two numbers, and you have to think of what they would look like if you extended them out of scientific notation. So we know that this would be 1, 2, 9, 8, 7. 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Perfect. So we have 1,298,700 plus 1,243. And then we know that we can just add the two of these together like so. Right? But what we want to do is we want to eliminate this step of extending it out into standard form. So what we're going to do is we're going to look at if we were just to multiply or add the numbers the way that they were, you would add 1 and 2,987 thousandths plus 1 and 243 thousandths. Now, if you look here, the 2 and the 7 line up. Here, both of the 2's line up. So we can't leave the numbers the way that they are because our place values aren't lining up correctly then. The reason being is our powers of 10. Right now, we've made these first numbers into a number that's between 1 and 10. So it's greater than or equal to 1, but less than 10. Okay, so what we need to do is we need to turn it into two numbers that have the same exponent. So what we do is we take the larger exponent and turn it into the smaller exponent. So what that means is I want to take 1 and 2,987 ten thousandths times 10 to the 6th, and I want to turn it into something times 10 to the 3rd because that's what I have here. So what this means is my decimal, since my exponent is going down 3, that means my decimal has to go to the right 3 places. 2, 3. So now this turns into 1,298 and 7/10 times 10 to the 3rd power. So now what I can do is, since my powers are the same, so my powers of 10 are the same, so now I can just add or subtract like normal. So now let's look at what happens. Let's look at how our numbers line up. And actually I have to erase this because now I have my 1, it's going to line up with the 8, which it's supposed to. My 7 lines up with the 2, and then my 4, 3, and 0, actually I don't even have to add the 0 on there. My 4 and my 3 are by themselves, which is right because this is where we add those extra zeros in. Because remember, adding zeros after the decimal is absolutely okay. And since I'm adding, I add these two numbers, so I get 3, 4, 9, decimal, 9, 9, 2, 1. So I get 1,299 and 943 thousandths. But this is that times 10 to the 3rd power. Now we know we can't leave it like this because the decimal is in the incorrect place. So I have to move my decimal 1, 2, 3 times to the left. So I get 1 and 299,943. So I get 1 and 299,943 millionths times 10 to the 6th power. Now what I can also do is I can check to see if I take that and move my decimal 1, 2, 3, 4, 5, 6 places to the right, does it match this answer? And I know that my decimal would be here, so I know my answers match, so I know that it's correct. Okay, so again, we have to make the larger exponent the same as the smaller exponent, so our place values line up correctly. So let's try this again. So I have 2 and 35 hundredths times 10 to the 8th, and I need to turn that into something times 10 to the 4th. So I know that means I have to subtract 4, so I have to move my decimal to the right 4 places. So I have 2, 3, 5, and I have to add 2 zeros. So I have 23,500 times 10 to the 4th. Now that these are the same, I can line up my numbers. So 23,500 plus 3 and 9/10. Add a decimal, add a 0. So I get 23,503 and 9/10. Then I know that I take and I keep it times 10 to the 4th power, because now both of these are times 10 to the 4th times 10 to the 4th. So I keep that. And I know that I have to move my decimal 1, 2, 3, 4 places to the left. So I have to add 4 to my exponent. So 2 and 35,039 hundred thousandths times 10. Oops, not to the 6th, to the 8th power. All right, so here, now I have a -6 and a -3. Again, you want to make your smaller like your bigger. And actually, let's not even, we're just going to stick with positive exponents for the time being to avoid confusion. So we're going to take our bigger and turn it into our smaller. So 5 and 76 hundredths times 10 to the 6th has to turn into something times 10 to the 3rd to match this one. So I move it 1, 2, 3 places. So I get 5,760 times 10 to the 3rd. So I take 5,760 minus 3 and 2/10. So I add my decimal and 0. Again, both of these are still times 10 to the 3rd. I bring down my times 10 to the 3rd. And I have to borrow, so this becomes 5. It becomes 10, but I have to borrow again, so that becomes 9, and this becomes 10. 8, decimal, 6, 5, 7, 5. So I get 5,756 and 8/10 times 10 to the 3rd power. I know I have to move my decimal 1, 2, 3 times to the left. So since I'm moving it 3 times to the left, my decimal goes up 3. So I get 5 and 7,568 10,000ths times 10 to the 6th power. Right. Again, the big part is that you're turning your number with the larger exponent into the number with the smaller exponent and then subtracting as normal, because you have to change these numbers so that way your place values line up correctly. Now, this only works with powers of 10 because of how you swing your decimal. This does not work with regular exponents. All right, so you have 2 problems here that I would like you to try on your own. As always, if you have any questions, Make sure to email me or write them down so we can go over them in class.